Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So let's solve this paper 6, the S2 paper of May June 2025 and variance 65. So people from the year 2025, now they have 4 variants in May June and 4 variants in October November. So from the perspective of S2, they have variants 61, 62, 63 and 65. The same thing goes over here. So now you have these 8 papers and then there is March and February. That is the variant 62. So altogether 9 papers in 1 year, which is very nice. Which is, yes, I know it's difficult to solve all those variants, but it's definitely worth it. So now let's get started with this. The first question. Now the question says the random variable x has a distribution which is Poisson. The sum of the 3 independent values of x is denoted by s. So basically s is x1 plus x2 plus x3. Show that they are being added. So 1.5 plus 1.5 plus 1.5, that is 4.5. Now it says find the probability s is less than or equal to 3. So probability s is less than or equal to 3 e raised to power of negative lambda 1 plus lambda square over 2 factorial. Evaluate this thing, multiply it with this and then round it off to 3SF. That's the first answer. Show that the exact value of probability s is less than or equal to 2 divided by probability s is less than or equal to 1 is 125 over 44. Now sometimes they go into too much of algebra and this is like one of them. So now e raised to power of negative lambda 1 plus lambda square over 2 factorial. Leave it as it is, write it down. This is an exact value. S is less than or equal to 1. E raised to power of negative lambda 1 plus lambda, and that is 5.5 over here. This is over here. When we divide, the two e's will cancel out. So let me highlight this, that this e will cancel out with this e, and then we are left with this. So this is 15.625 at the top and the next one is 5.5 at the bottom. So now this is written like this and then you can use basic maths. So what I've done is that first I divided by 25. I got these two because I was not having a calculator, a scientific calculator at hand. I was using my phone, and then we divide it further, or if you can just plug it in over here, that would give you this value, which is exactly what they have asked. Question number 2. Now it says this thing that we have a random sample of 200 values of a random variable x. N is there, sigma x minus 2 is there, sigma x minus 2 whole square is there. So in the previous video that was uploaded, if you want to check it out, that is May, June 2025 variance 62. I specifically said that from S1 they can ask any basic stuff. That basic stuff could be about coding, that could be about DRV, that could be about frequency distribution, the mean and standard deviation. That could be about permutation, combination, NPR, NCR. It could be about conditional probability. So yes, all those basic stuff can be asked. So over here, they have asked about coding. So now let y is equals to x minus 2. So this thing is written as y, this thing is written as y. Therefore, this is sigma y is 60 and this is sigma y square is 20. So now we are calculating y bar, which is sigma y over n, that is 60 over 200. Therefore, if I make x bar the subject, so y bar is x bar minus 2. Therefore, x bar, if I make the subject, it's y bar plus 2. So this is 0.3. I add 2 to it, that is 2.3. And if they are asking for the variance, so standard deviation of y, it has to be in terms of y, sigma y square over n minus y bar square. So this is 20, this is 200, this is 0.3. So don't forget, this 0.3 is that what we are using. This is y bar. And then we get standard deviation for y is this thing. That is the same thing as standard deviation for x. It's a rule that due to subtraction, our variance or standard deviation remains unchanged. So now use the unbiased estimate. Unbiased estimate of population mean it's n over n minus 1 into sample variance. Unbiased estimate of population variance. I think I mistakenly called it mean. Unbiased estimate of population variance, it's n over n minus 1 sample variance. That comes out to be this value. This is 1, 2, 3, 4, 5. So I'm working in 5 SF, which is perfect. The formula for confidence interval, that is x bar, which we already have over here, 2.3 plus minus z sigma over root n. Now this thing is sigma square. So instead of sigma, since that was not given, we have to use the unbiased estimate. And then how do you get the z value? They're asking for 95% confidence interval. So 95% is symmetrically placed between two values, 2.5% on the left, 2.5% on the right. So for this value, we read it for how much? 97.5%. That is 1.96. You evaluate, you get this lower limit, you get this upper limit. State which part of your solution make uses of central limit theorem. Now in this formula, in order to calculate this thing, the z value is used. So unless and until it is normal, how can I get the value of z? So since the sample size is large, CLT applies. That's where we are using it. Let's look at question number 3. Another nice question of sampling the random numbers thing. So M calculator can generate random numbers between 0.000 and 0.999 inclusive, correct to 3 significant figures. She plans to use a calculator to choose a random sample of members from the 851 members in a health club. She numbers the members from 1 to 851. She then uses a calculator to generate some random numbers. She multiplies each random number by 851, round up to the next whole number to give the number of a member in the sample. This is called a member number. Now M first random number is 0.401. Find the member number. That's very easy. Take this number, multiply it with 851 and then round up. So if I round this up, what do I get? I get 342. So that 1 mark is just basic. Now let's focus over here. It says find all possible random numbers correct to 3 decimal places. That would produce the following member number. So a member number of 680. Now first of all, let me write 680 over here. This is R into 851 is 680. So R comes out to be 0.7999. That is a 3-digit number. Now it could be a possibility that this number came out to be 679.1. According to the rule, it became 680. So let me find the corresponding R, the random number for that. That comes out to be 0.798. What if this is 679.01 or maybe 001? Still, I'll round it up. So let me evaluate with 679.01. R comes out to be 0.7978. So therefore, can I write this thing as 0.798? This is 0.799. So my final answer for this part is 0.798 will also give me a member number of 680. 0.799 can also give me a member number of 680. So these are the two numbers that are possible. Now a member number of 850. So now again apply the same rule. R into 851 is 850. R comes out to be 0.9988. That is 0.999. And what about the same thing? What if I got 849.01? So R into 851 is this thing. Now this is 0.9976. It will also round off to 0.999. So over here, the final answer is 0.999. Now look at the two things. Over here, I have two different numbers. Let's say this is this number. That is 0.798 and the other one is 0.799. Two different numbers are giving me the same member number of 680. That means two different persons can have the same member number, which should not be the case. It should be something unique. Over here, the member number of 850, that is only obtained by this thing, by one number, which is 0.99. So now here is the reasoning part. What are they asking? Explain briefly how your answer to part B shows that M method does not produce a random sample. More than one value will round off to the member number. So therefore, this will be biased. There will be repetition. So this is not the right way of choosing a member number. So that's the logic over here. Let's move to question number 4. Now it says the number of cars and trucks. So there is car and there is truck. So this is car. That's the distribution for car. And this one is truck. And that's the distribution for truck. So now they have variables such and such, and that variable was for per minute. Find the probability at least 4 cars, at least 4 cars, at least 2 trucks, at least 2 trucks arrive at the fuel station during a chosen 5-minute period. So we are multiplying by 5, we are multiplying by 5. So this 0.8 is multiplied with 5. This 0.5 is multiplied with 5. So therefore, this is 0.8 into 5, that is 4. This is 0.5 into 5, that is 2.5. Now what are they calculating? It says at least 4 cars. So C is for car, greater than or equal to 4. 1 minus probability, C is less than or equal to 3. E raised to power of negative lambda 1 plus lambda square over 2 factorial, lambda cube over 3 factorial. Don't forget this minus sign because we have to subtract in order to get this. That comes out to be this thing. So the answer for at least 4 cars is this much. Similarly, the answer for at least 2 trucks is this thing. So over here, we did this. T is less than or equal to 1. E raised to power of negative lambda. This is a different lambda. 1 plus lambda. Again, simplify. You get this answer. Work in 4SF, 5SF, no issue. But final answer should be 3SF. Now it says this word over here, that is and. This will happen and this will happen. So and means multiplication, and we multiply these two because these two are independent of one another, and the final answer is over here. So that was a nice simple question for 4 marks. That is part A. Let's move to part B. Now it says use a suitable approximating distribution or suitable approximation. Find the probability a total of fewer than 145 cars and trucks arrive at the fuel station during a randomly chosen 2-hour period, that is 120 minutes. So now first of all, this is C, that is 0.8, and this is T, that is 0.5, that is per minute. But how many minutes are we taking into consideration? That is 120. So add them, multiply by 120, we get 156. Now you would say, since lambda is greater than 15, therefore x follows a normal distribution, lambda comma lambda. Why? Because we know that expectation of x is lambda, so is variance of x, and that is the justification. Now also don't forget to show the working for continuity correction. So this is 145 and this is 145.5, this is 144.5. 2 lines can be drawn, one going this way, the other one is going this way, and they are asking fewer than 145. So fewer than 145, it could be 144.5, it could be 145.5. Why is it 144.5? Because it's not inclusive. So that is why the green option is the right option. The green option is the right option. That is 144.5. Subtract the mean, divide by variance. We get this thing. Z is lesser than a negative value. That's the same thing as Z greater than a positive value. That is indirect reading. Go to the normal distribution table. Read off this value. Let me highlight it. This is from the Z table. That is the Z value. This is the probability value. And then subtract it from 1, and then don't forget to round off. Yes, too many things to do, but that's how you will earn your marks. There are no shortcuts in life. Question number 5. Now let's read this part. What does it say? It says candidates for a certain diploma take 2 tests. The mark for the first test and the second test are modeled by independent variables. That is for the first, that is for the second, respectively. The final mark for each candidate is found by doubling the marks. Multiple concept is there in the first test and then adding the result to marks in the second test. So now X is for the first test. So X stands for first test. And then Y stands for the second test. And now the first test marks are doubled. So I have written down an equation. The final mark, that is 2x plus y. So expectation of 2x plus y, that's 2 times expectation of x plus expectation of y, 2 times 38.1 plus 64 from here. Let me just write a 0 over here so that we are following that exact same thing. And then variance, what happens to the variance? Variance of 2x plus y, that's 2 square times variance of x plus variance of y, that is 4 times 3.8 square plus 6.1 square, that comes out to be 94.97. Okay, this thing is done. Now it says f bar follows a normal distribution, 140.2, 94.97 divided by 25. So now over here, not this much is linear combination. So this is a perfect question. It is of linear combination. First we did this, and then it is a question of sampling. So now it says find the probability the mean f bar of the final marks of a random sample of 25 students is greater than this. So now over here f bar follows, that is the mean from here, that is the variance from here, this is the number of sample, and then we know that z is x bar minus mu sigma square over n under root. We do this thing. This is x bar minus mu sigma square over n, the whole thing under root. Z is greater than a positive value. 1 minus phi of that value. So now we do this final answer, and that's given correct to 3SF. So that is question number 5. Let's look to question number 6. Now it says it is claimed that 28% of the voter in a certain town support this political party. A researcher suspects that the true figure is less than 28%. She interviews a random sample of 30 voters from the town. She finds that 4 voters in the sample say that they support this party. So 4 is the sample value. She plans to carry out a hypothesis test. Use a binomial distribution, carry out the test. So now 30 is the number of trials. 28% is the probability of success. Sample value is 4. Alternative hypothesis is lesser than 28%. That's the 10% significance level. Now again, look at the working. This snippet that I've pasted, that is from the mark scheme. This is what I'm writing over here. Probability x is 0, 1, 2, 3, 4. Probability x is equals to 0. That is 4, that is 30 C0. Let me write it. 30 C0. Success raised to power of 0. Failure raised to power of 30. That is this thing over here. Then it's 30 C1. Success raised to power of 1. Failure raised to power of 29. Let me just highlight this, hold for a second. So now this is 30 C2. Success raised to power of 2. Failure raised to power of 28. 30 C3. Success probability raised to power of 3. Failure probability raised to power of 27. 30 C4. Success raised to power of 4. Failure raised to power of 26. Now make a habit of writing this thing down. In Poisson, you can just work out what's in the bracket and then multiply with e raised to power of negative lambda, whether there is a minus before that or not. That's the working. For binomial, work out every single thing correct to, I think 4SF is perfectly fine. So now this thing is done. That comes out to be 4.95%. Is it lesser than 10%? Yes. What's the conclusion? Reject H0, accept H1. There is sufficient evidence or significant evidence at the 10% significance level, to support researchers' suspicion. Now, what has the examiner written? Let me read it out. So it says there is sufficient evidence at the 10% level to suggest that the percentage who support that political party is less than 28%. That's another way of writing it. I have written from the perspective of suspicion because that's what the question was all about. State with a reason whether it's possible that the type 1 error was made. Yes. Why? Because H0 is rejected and type 1 is related with rejection region. Since H0 is rejected, type 1 error will occur. What is the wording of type 1 error? Reject H0 when H0 is true. So yes, type 1 error will occur. Later, researcher carried out a similar test at the 10% significance level using a new random sample of 30 from the town. Find the probability of type 1 error. Now here comes the container thing. Now the container has a capacity of 10% significance level. We know that probability X is less than or equal to 4. That is way smaller than 10%. That means that is almost half full. 5% is still left. So now if I just calculate this probability and add it to this, that is exceeding this. So let's say this is 5 and this is what? 6.6% approximately. So just this much won't fit in over here. So therefore we discard this. The critical region is this one, that is 0 and then 1 and then 2 and then 3 and then 4. So all these are critical region. So critical region is X is less than or equal to 4. And again read the question. That means if less than or equal to 4 people vote for political party, that one, the what you call people who are fan of that political party, that is now rejecting H0 and accepting H1. So that is the critical region. So probability of type 1 error is the probability of the critical region, that is 4.95%. Another question. Now it says, a firm makes certain types of battery powered toy. The battery life is denoted by X hours. The population mean X is supposed to be 12. The quality control department wish to test whether the population mean is actually lesser. So now they are getting suspicious. They want to check for quality. They tested a random sample of 50 of these toys, found the sample mean X bar was 11.4, state suitable null and alternative hypothesis. So now over here, first of all, H0 mu is 12, H1 mu is less than 12, 1 mark for this thing. Now this thing that I've written over here, that is for the next part. Because first of all, tell me this, does it say it follows a normal distribution? So battery life X hours, population mean, quality control department, no. So I have to write, since a sample size is large, what is the definition of sample size? N is greater than or equal to 30, therefore CLT applies. Because if CLT does not apply, how can you involve Z over here? Now you may assume that the standard deviation of the battery is 2.3 hours. Show that the value X bar leads to the rejection of null hypothesis at the 5% significance level. So Z value X bar minus mu sigma square over N, the whole thing under root, that comes out to be negative 1.845. It's a lower tail test. So therefore the critical region starts at 1.645. And this is negative 1.845. So that lies inside the critical region. Reject H0, accept H1. That's all they are asking. We are not writing anything as conclusion. So since the corresponding Z value lies inside critical region, that is why H0 is rejected. Now it says it is given that X bar is 11.4 leads to rejection of null hypothesis at the alpha % significance level. Find the set of possible values of alpha. Now, if I choose this thing and if I write negative 1.845, so let's say this is negative 1.845 and this is alpha % significance level. That means in order to find this, this is what I need to do. Probability Z lesser than or equal to this. That comes out to be 3.25%. That means if the significance level was, for example, 10% and this was 1.282 negative, still it would be rejected because it would be in the critical region. So this is the minimum value. Therefore, we put a greater sign. Set of possible values of alpha, it could be 100% significance level. Everything is over here. So, of course, we choose values like 10%, 5%, 2.5%, 1%, and so on. So, the minimum is 3.25% because the boundary has to be inside the critical region. The boundary is starting from here. So, the minimum value is 3.25. Find the set of possible values. It should be greater than 3.25%. Okay, now this thing is done. Question number 8. Now, the previous paper that we have seen, for which I've made the video, the May-June 2025 variant 62, that also had 8 questions. This also has 8 questions. Now it says the diagram shows the graph of the PDF of a random variable X between X is equals to 0 and X is equals to A. This is 0, this is A is positive. The graph consists of a straight line through O. That means the y-intercept is 0, gradient is k, where k and a are positive constants. Elsewhere, fx is 0. It is given that median is root 2. Find the value of k. So if the median is square root of 2, that means x lesser than or square root of 2 is 0.5. Square root of 2 is the upper limit, 0 is the lower limit, k I have put it on the outside, x is integrated, becomes x square over 2. This 0.5 is written as half. So now k over 2, that goes on the outside, plug in the upper limit, plug in the lower limit. So the upper limit is root 2, that is plugged in, squared, plug in the lower limit, squared, and then we solve and we get this value, that is k comes out to be half. So find the value of k, that is half for 4 marks, for 2 marks. Find the value of expectation of x. Now the first thing is I need to find the value of a. How can I find the value of a? There are 2 methods. Now first thing first, if this is the equation and if this is a and the equation is fx is kx, correct? So why is it kx? Because the gradient is k and the y-intercept is 0. So y is equals to mx plus c. So y is equals to kx plus c. That's how I get this kx. So if I plug in a over here, the corresponding y coordinate is ka. And then if I want to find the area of the triangle, that area should equal probability. So this is method number 1. So this is method number 1 for finding a. Half into base into height. So this is the base a. This is the height ka. This equals to 1. This 1 is the probability area under graph. Therefore, a comes out to be positive 2. That is method 1. Now let me do using method 2. So if I write over here method 2, that is using integration. So this is method 1, that is using area of triangle. So this is area of triangle. This is integration. So if I integrate the function x between the limits 0 and a, the k is there on the outside. And these are the limits. So I also find a is equals to 2. So again, this a is coming out to be 2. So I've done it using 2 methods. So this is technically step number 1. This one on the right hand side, that is step number 1. And then this is step number 2 of finding the expectation. So expectation of x, that is x into half x square. That is integrate half into x cube over 3. The 2 and 3 multiply to give you 6. Now again, plug in the upper limit, that is a in x cube. Plug in the lower limit 0 over here. That is 1 over 6 a cube. The value of a is 2. And this comes out to be 8 over 6 or 4 over 3. That is the expectation. So that completes this paper, which is May June 2025, the new variant, which is 65. So let's stay tuned for more papers to come on P3, S2, P1, M1 and S1 at the YouTube channel Mathematics with Shahab Yaqub. Take care, everyone.